Okay, today we are going to speak about, it's the first session for data cleansing. Now, we are going to simplify the concepts and trying to reach to great good point, which is selecting automatically or orchestrating the data cleansing pipeline. Let's say at the end of this series, I think it will be 3 or 4 sessions. So we will start from this point up. I will show in 5 minutes only what is the data set that we are going to use during these sessions, and then I will start the routines or the functions that I'm using. I will focus on pandas with NumPy to make the cleansing, and we will import the database using the CSV files. That means we are not using databases, not using SQL. We know already, according to our sessions, how to move from relational data set to pandas data frame. So we will start from the data frame itself. Now, I'll share my screen. Okay. This is our dataset. I have here 3 CSV files. The first one, we name it claim dataset. It just contains a set of claims, medical claims, with the date of these claims and what is the type of the claim, outpatient or inpatient. This is the first one, the first file. Now, the second file, we know already, we discussed about this previously, that we have the medical claim contained mainly from the claim body, which is the basic information of the claim, and then what is the diagnosis of this patient and what is the treatment or the procedures performed. So we have these 3 entities in our dataset as 3 CSV files. So the second one is the activity dataset. Activity, that means it's the treatment, what we have. So we have the claim ID to tell us which claim is belong, this claim, this activity belong. Then we have the activity ID. Activity ID, it's only unique number within the claim, in the claim itself. That means it might be repeated for other claims. Then the quantity of this, either it's medicine, that means how many boxes it's dispensed for this, or if it's X-ray, whatever was the procedure, we have a quantity. Then the item code might vary on the, let's say, on the format. So if, just I will tell you this, if we have this kind of item code, it will be medicine. That means it will be drug, okay? Otherwise, it will be procedure, either X-ray or some medical procedure performed by the doctor, whatever. So this is the 2 kinds of procedures that we have. And from the item code, we can define it. Also, we have the item external code. Item external code, it's telling us if it's 3, that means it's CBT, that means it's a procedure, or if it's 5, it will be a drug. So almost we have to compare. This is from the data source, it's giving this information. We have to know that if it's 5, that means it's a drug. So it's expected to find this format. If it's 3, that means it's CBT. Then we have the net amount, which is the cost of this procedure, or on the claim level, we will discuss about it later. We have the paid amount, net amount, that means it's the claimed amount. Payment amount, it's what insurance company approved to pay. And then we have the denial code if it is denied. Guys, I will check the chat. Yes.
Real quick there, Kim's correct. I was wondering if I should say anything. There's a bad feedback coming from your microphone somehow. I'm not sure why. It's like a buzzing sound when you talk.
Okay.
Maybe try
should
to
I change this headset?
Try that first. That might be all it is.
Slide.
Oh, okay. Okay. I will change it. Just a minute.
Yes. So while he's changing that, let me explain something that you guys maybe already know. The breadth of dirty data you can encounter is endless. But what's nice is over time, you start to just get a sense of routines you can write, both at the pandas level, even at the SQL level, but definitely at the Python level, at the NumPy level, there's there's different ways always to be able to automate cleansing the types of dirty data that you encounter. And for each type of data set, as that data is flowing in, you typically discover pretty quickly the types of dirty data you're going to encounter and how you can deal with it. And I've yet to see a form of it that you can't automate. For example, I was dealing with some automated web testing the other day, and it was quite possible. I was capturing these links, and one of them kept messing with me, and it was just because the website I was working with automatically capitalized something when it normally didn't. So all I had to do was go into certain routines and make them all go to lowercase. But
is it better right now?
Do your wrap thing and let's see. You'll have to talk more. I think it will be.
Okay, so currently we show what is.
It sounds like it's a computer system issue.
Okay, so I will log out and log in 1 second. Okay.
Okay. I'll keep talking.
Okay.
But like I was saying, once I identified the culprit, I just had to find out how to deal with it. And now, what's the great thing is the whole routine is more robust now. And again, it was a type of data dirt I had not yet encountered. It's almost like we're on a well where I live, and the system we originally put in was not appropriate for our house. We needed a system that was just a big, like a coarse filter that would catch, visible particulates that we could, bypass and shake out and put back in, so it wouldn't clog up the fine paper filters so frequently. And so it's that same spirit of, you may have dirty data dealt with at one stage and another. I think I might be telling you guys stuff you already know. Let's try it now, Guy.
Okay, I hope right now it's better.
It's different, but not better.
Okay, no, this is strange. It's really
try
strange.
to let it hang down. It could be that your system's trying to overcompensate for it being near your mouth. Maybe something changed system-wise. In other words, just let it hang down and see if it'll adjust.
Okay, I will try. I'm trying right now. Maybe it will be better.
It's no different, but it's funny. It's not affecting the volume. It's like your mic volume is maybe too high.
I'm trying. I'll check from the setting.
Yeah. I'm really glad, though, that Guy is showing it from the medical area, because I have never seen those. And but just because of the other ones I've dealt with in the past, and like started to imagine right away, oh, you deal with that this way and that way.
Right now, is it clear?
That's the best so far.
Okay. Hopefully it will be the best right now. Okay.
I think you don't. I don't think you have to wrap it near your mouth today. Okay. There you go.
Okay. So I will share my screen once again. Okay. Now, just I was going to show the third data set, which is the third file, which is the diagnosis. It's showing us what is the diagnosis and the type of diagnosis for each claim. So to understand it, we have the claim. We can find it on the 3 files. In the first file, we have the headings, it's only the claim ID and some, let's say, master information about the claim. And then we can find the detail of the activities as the procedures, and which is contain the prices, and the negotiation will be there. And then we have the diagnosis. Our target, let's say, if we use this project during our journey, our target is to build a model to predict if this claim is going to be approved or not. Okay. That means we will build a model to predict the approval of the claim. So it's classification task to tell us if the claim is being approved or not. So we have two classes, approved or rejected. We might make it more, but let's say this is the first task. Okay, I will continue right now. I use the Visual Studio for this project, for this task during these 3 sessions. In Visual Studio, I will show just quickly how to create a general Python or even classification Python project. But here I'm using another kind of Python application because I'm thinking about the third session, which is how to orchestrate or which kind of orchestrator we are looking to build, because we are not going to use here the orchestration tool, one of the famous one. No, I'll show you how we are able to build it, to understand what's the orchestration tool doing and how to create. But in general, we showed this previously on the support videos, but in general, we are able to run the Visual Studio. It's not the Visual Studio Code, Visual Studio community. And then we are able to ask for building a Python project, and Python project comes with multiple templates. One of these templates is regression template, and the other one is classification template. So in general, this is how it will be. So if I create a new project here, I will be able to choose which language I'm going to use. That means it's Python, C#, whatever, all the languages that you included while installing the Visual Studio, and then which template. Right now we are looking for Python application, all platform. That means you might build it for Android, for Windows. It's depending on what is your target, and then all project types. This is the all project types of Python, including also some Flask projects, which is help you to build APIs, or Python application, just like what I have here, which is help you to build somehow of desktop application, Windows application, and so on. I'm not going to build a new one. I will use the current one, which is already built, and this will be included on the GitHub repo, so you can get it. And if you want to do any modification, you can do it in your local version. Now, to summarize what is the data cleansing, I can say we have 4 major tasks in data cleansing. And it's not the only, but this is, let's say, the major. Especially in our case, when we're dealing with dataset, we have to on CSV files. The first one is normalizing. I name it like this because it's coming from relational database concept, normalizing the data. The second one is processing missing values. The third one is checking the duplication and how to fix it, and how to fix non-value fields. And the fourth one, the fourth task is to build your, let's say, data pipeline, data cleansing pipeline. Which kind of processes will be included in your project? So right now we will start to explain our processes, our mechanisms, and the last section it will be how to select what is the best process for a specific case. I'll try to check the chat. Still software, it might help. Okay. Keep trying my band. I've never heard your audio. So Tom, tell me what I have to do.
Yeah, so it's not that we can't hear you, but every time you talk, it's like there's additional electromagnetic noise. And by the way, Guy, unlike usual, I can't tell a difference between when you put your mic like that and you hang it down. It's almost as though the system's overdriving right now, but it's only when you speak that it starts adding that additional noise. But I know that from my own studies, the thing that will most distract your listeners is bad audio. It's not that your audio is bad, it's that it's adding a lot of noise every time you speak. You've never had this issue before, so it almost makes
that's why I don't know what to do.
Because I know, I hear you. But I would let it hang and just try to talk softer. It might itself up because we can hear you fine when it's hanging down.
Okay, I will try. So first, let's see how to let's say to build our data frame from this CSV files. So here I build a class and then I'm create instance from this class, which is the cleaner instance. And the first thing that why the main loop, because as I told you, I'm going to use it on the Windows application to build orchestration. So I'm just passing the file path. And what will happen here? First of all, I'm calling the read CSV file. This is the command. This one, it's returning the data frame immediately, and I'm able to show it. What we have here, it's simple. We are reading using the pandas, which is we imported already. We are reading the file, the CSV file, and then return it back. So if we simply just print the head file, that means the top head row, 5 rows on this, we will be able to see, the 5. I'm using here the activity file, that means the procedure, because this is what the main file that we need. So here we can find that we have the top 5 rows in this CSV file. Okay, and then the second one, I'm printing the full data frame. You can see that we have 540,000 rows in this data set. Okay, I will start from here. We can see that transaction date is always not a value, not a number. And also it's not a value. Let's check what we have for this in the data set itself. The transaction date, it's always empty. That means we don't have this information. We have it as a heading, we have it as a title, but we don't have anything to tell us what is the transaction. This kind of information, it will not help us. It's always good to remove it from our dataset, especially if we know that that means we have expert person or the business analyst telling us, yes, it's really not needed. So here we are talking about the technicality, how to remove it. I will call this one a drop. Before calling drop unified item, I will tell you how to check if the column is, let's say, how to drop the column from data frame. So we have this method called drop column. In general, we are passing the column name and the data frame, and then we call the drop function, drop method from this data frame. So we passing the set of columns we are going to drop from to drop, and then in place, and then what is the access point. Return the data frame, it will return the data frame after modification. In this case, we need the column name. That means we are looking for a specific column name and we are going to drop. But how to use this function in a better way, which is here, a drop unified columns. Drop unified columns. In this method, I'm going to drop all the columns that have only one value. That means for 500,000 row, always this column comes with only one value. This column is paying nothing to our dataset. So simply we are checking that if how many unique values we have on this column. That means sometimes the column, for example, just like what we said about the claim type. Claim type, sometimes it's outpatient, sometimes it's inpatient. So the unique values length, okay, it's 2 only. So I'm just passing through all the columns and checking how many unique values I have for each column. If the length of the unique values is only 1, that means all the rows in this data set for this column have the same value, then I'm able to drop. So I will call the drop function that I built previously. So right now, let me activate drop column, but drop the unified column, not drop column. Okay, and see how it will how the data set will look like. Simply, we can find the first one. This is printing the head 5, which is the first 5 rows. And then I'm printing the full data set, the full 5. And including to that, I have this transaction date, not a number. I have it here. And then when I drop it, I drop all the columns that have only one unique value. That means for all the data set, for all the rows, this column only have one value. In this case, I drop only the transaction date. So other columns, always it's varied. That means it's not only one value. Okay, so right now I've finished with 8 columns. So this is one normalization way that we have to drop the columns that didn't play, it's clearly didn't play any rule to our data set. Now, is this always correct? We have to always back to the business analyst, back to the experts, domain experts, to tell them that this column is not telling us anything. Is this the case for you, or what will happen? If they have a clear answer, we can maybe drop it with strong, let's say, we are strong with our decision. But if not, we have to take care and think twice before dropping. But this is one of the normalization. The other one is, in general, when you are dealing with data frames, we need to think about the identity of the rows. Just like what we have in the database, we have something called primary key. The data frame, if we have index, if we have unique value that tell us, let's say, identify the row, this will help us better for finding the suitable values and making some modification for later. So how to do that? We have, I'll check the chat once again. I have a guest check that Zoom is using the headset microphone and not your computer microphone. Okay, I will try. I will check. Just Tom, if it's okay, not perfect, let me continue.
Yeah, go ahead and continue. I was hesitant to even say anything. This is great material, by the way. And I loved what you emphasized, Gaith, about it. Guys, nobody wants to delete a whole feature, but literally there are times where you're looking at a feature and there's almost no data for it. I mean, by the way, I'm looking at a data set recently that has 5% of the values. And I'm thinking, I can't even talk to a domain expert on this particular feature. I made the decision, I'm deleting it. I can't even use the other features to predict how to fill it. So it happens.
Okay, now we have 2 methods here, 2 functions I created just to show us what is the value of the identity. Okay, the first one is looking for identity columns. That means we will check if this data set, this CSV file, has identity column. Now, it's not named as identity. At the end, it's CSV file. That means it's kind of text. But if there is any column in our data frame, might be accepted as identity or not. How to check that? Identity column, all the values has to be unique. So in this case, if there is no any kind of duplication of the values for specific columns, we can accept this column as identity column. So what I am doing here, simply, I'm going for all the columns and check if this column is unique. This is unique, telling us either if this column, there is no repeated value on it, or there is a repeated value. So if it's unique, I'm adding to the dictionary here, to the result dictionary, that this column, the column I, is unique. If not, I'm adding it's non-unique. And then I will show this dictionary. Let me also doing the same. Just let's say, look for identity column. I will activate this one and run the project to see what's the value that we are going to use. Okay, here claim ID is non-unique. Activity ID is non-unique. Now, why it's non-unique? Because I told you activity ID, according to our generating method. Activity ID is unique for specific claim, but in the general, it's not non-unique for all this data set. Quantity is non-unique. Item code is non-unique, simply because drug or procedure might be repeated for different patients. External item, sure, it's non-unique. Net amount is non-unique, might be repeated, especially if the net amount was 0, for example. Transaction date is non-unique, simply because we know transaction date is all null. So we don't have any identity column here in this dataset. So this is one method. The other method, it might be simpler. Right now, I'm making a report about the whole columns, which one is unique. But sometimes I don't need to do that. I just want to check if there is a unique column or not. And then if there is no unique column, I will create identify. So I will print this and check what this function. Okay, this function is calling another function called HasIdentity and pass the data frame for it. So if we don't find any identity column, okay, simply we have to create one. Now, how to create one? We are inserting a new column in the position 0. We name it a new ID, and then the range of values, it's starting from the start value, which is I pass it 1 in the beginning when I call the function, and for the length of the data frame. So I'm checking first if I have identity column. I'm not going to create index for this data frame, but if I don't have, I will create index. So what HasIdentity did, it's similar to the first one, look for identity columns, but in general, it will break once it finds one identity column, one unique column. That means it will return true and break the full loop. In this case, it will be faster to proceed for it, so no need to wait. I found what I'm looking for. So I create function and I call it on another function to perform my task. Now I will run this and see what is the value printed in this case. Okay. In my case, this is for sure we couldn't find any new ID column. So what we did, we just create this one, new ID, and the value started from 1 to the end, to the length of the data set, and all the other values is there. Now, why transaction date is appearing? Because I stopped removing it. If you remember, I just comment that command. So that's why it's still there. Now we can find also we have 10 columns. Now, what we did here in general, always we are doing one thing. We are creating function. Somehow it's generalized. That means when I'm talking about column name, data frame, I'm not thinking about which CSV file I'm looking for. Until now, I didn't use any column name by name. That means if I just here, I comment this one, this instance, and I create another instance, and this instance having the values from claim dataset, not activities dataset. I'm still able to do the same to the claim dataset. So this function is considered generalized function, and we will try to do the same for all other mechanisms or processes for data cleansing during these sessions. And then we will find how sometime we need to customize it. Okay, I'll just give it a run right now to see what will happen. By the way, it will be break because I'm passing one of this. Oh, okay. 3 columns. I think it's break here. Oh, okay. Now for this one, you find there's only 3 columns. That means it didn't create a new index. Why? Because in the claim dataset, the claim ID is unique. It's our master table. So we have a unique column. And you can find here, it's telling us claim ID is unique, while claim ref date is non-unique and the claim type is non-unique. Okay? So this is what's the reason of showing this example. I'm just changing the data set, but the same function still running. Now, the other process that we need sometimes is to confirm the data type. Also, it's considered of the normalized data set, normalizing the data set. So how to confirm the data type? For example, we have item external type, this column. It's telling us, as we explained already, it's kind of encoding that if it's free, that means it's procedure. If it's 5, that means it should be a drug. And I can, by the way, this is standard. This encoding is standardized for Abu Dhabi Health Authority, and we can get it free to share it. We can get the full encoding method for the external type, which is that means the procedure type. So right now we only have a 3 and 5, so no issues. But we are sure that this value has to be int. So just we are able to force the data frame to make the data type as int. Simple. And then we can print this column to check. Now, again, the determine data type, it's built also to be generalized method. So I will go to the definition, right click, go to definition, it's forwarding you to the function. Simply, we are changing the column name data type to the requested data type for this data frame using as type. For sure, this one, if there is any mistake, it will raise an error. So later, next session, we will start with this. Processing the error might appear here and what to do. And then we will move to other processing the missing. So just I'm going to run this one to see how the data type for this one, for this column, it's changed to integer since it's accepting integer. So we can find that we reprint it and we find the values. And at the end, the data type is N32. Okay, so right now we are sure that item external type is integer. So this is one method. It can be used also to confirm the data type, and it will help us sometime to process the error might appear according to the format change. Now the most clear example is not about the N, it's about the date values and how it might be reflected or conflicted with the string. I will stop here because this is what's ready from my side first, and second, because my voice is not clear, and also to get your questions.
If it's appropriate, Guy, let's take questions first, but I wanted to show, this was so good, by the way. And it is lightning fast to deal with most, even fairly large data sets using pandas. You can, if you get into gargantuan data, you might want to use something other than pandas, but most of the time it's been very rare. I couldn't clean data with pandas, but oh, Kim has a question.
By the way,
let's see.
Okay, I will get the question from Kim, but I want to highlight one thing. We already discussed how we are able to use store procedures or to create procedures, SQL procedures, using SQL Alchemy and call it from pandas. So according to that, some of these, if we have access to the database structure, we can do more advanced method, customized for a specific database. But right now, what I'm trying to on the database and call it from pandas also. And also we can include it in our structure for orchestration. That's what we said, that we will choose what's suitable for us. But what I'm trying to do right now, it's whatever we are doing, it will be useful for any data set coming as CSV file, which is right now what we are dealing with. So any one of these functions can be used always. Always. That means no need to think twice about it. It can be used always, unless the last one. The last one we need to modify later in the next session. Yes, Ken, sorry. Should I stop share first?
No. Actually, okay. I think you just answered the question. So basically, My question was it fair to say that you're showing ways to identify unique variables and empty data sets in a way that can be automated so you can use the same functions going forward for data cleansing without having to necessarily review all the data that you're running through it? So it's like an identity thing.
Yes.
Okay.
Now, but again, let's say we are dealing with, by the way, this data set is not perfect. It has a lot of features. Right now, I'm not going to explain to you, but I will tell you exactly what's the most important feature that we might find. Here, even on the claim data set, right now it's here, the claim table. Here it's compact, but even with the extended one, I don't have the physician specialty. And this is, I keep it as a missing value example. So we are going to explain it in more details and how sometimes we might create a model just to predict one missing value. So it's not simple, let's say, it's look like fantastic data set, but the data set has a lot of problems. So, and it's good for our case because it will help us explain exactly where it can be generalized and when it cannot, you have to deal with it as customized schemes. Okay, check the chat.
Okay, and Guy, also Jaya had a question above. What is an example of a unique identity column?
So Guy, like each row, right, has unique values. I thought each row is like a dictionary, right? So it has a key and a value. So I guess I'm not very clear about this non-unique.
Okay, if you are look at from this point of view, if you are looking for the dictionary like this, our unique value, what it will be in our dictionary. By the way, it's at the end, the data frame, even if you think about it as a dictionary, the unique value is the column name.
Right.
But there is nothing telling us about the row value. That means if I want to reach to a specific location, there is nothing telling us where is this location. I mean from the row point of view, not column point of view.
Okay.
Okay, this is why when I'm talking about this column is unique, that means it has for each row a unique value. That means identity value. So this is the value of identity. It's for reaching the row. And by the way, in data frame, if we use I think location, it's LOC, the common. You can move directly to that location, which is if you pass the index or you pass the identity value.
Mm-hmm. So say if a column has the same date, say I'm looking at your Excel sheet here, 25th of June, right? So that's like, lots of 25th of June, right? So that's non-unique. Is that what you're saying?
For sure. But yes, exactly. But this one, the claim ID.
They're all different, right?
Yes, exactly. This one, it's all different. That's why in the claim data set, we didn't create a new one. We have already.
Mm-hmm.
Now, maybe we need to, let's say, make some engineering for it. Maybe we have to not numberize it. But at the end, we have something unique.
Mm-hmm. So the only time it's going to be unique is each row has a different value. Okay. Otherwise, it's a non-unique because it might have June 7th could be like 10 rows, right?
Exactly.
Okay,
and more.
got it. Okay, gotcha. Thank you.
Thank you. Okay.
Guys, if we have time, by the way, this is really good. I've got a couple of functions that I've created myself that I use over and over that I think.
Okay, I will stop share first.
Yeah. Okay, great.
And you can right now forget about one.
Okay, let's see. I'll just do it at, there we go, right here.
So why Tom's just bringing that up. So the unique column or the unique identifier is basically identifying a record or a row within that data set. That it's a key. It's like a key to that row.
Exactly, just like the primary key in relational database for table.
All right. Yeah, good questions. I hope, by the way, this is the least sexiest part of data science, right? Let's all agree to that. Okay, so dealing with NANDs. I had to do this over and over so much at one point that I created these two functions. This is the first one. It just gives me an initial visualization of the NAND density of a data set. And so this is in a fractional point. So obviously this is approximately 6% of the values in this data set or not NANDs. And so the way it's working here is first looking across the data set to say, I want to know, is it null? Then I want to sum that by columns and rows, but I want to know the number of columns and the number of rows in the data set. So that's how it accomplishes that ratio. And then it just returns the NAND density. And there it is. But then I thought, well, okay, that's good to get an initial survey, and that already causes me concern. And by the way, we did successfully move the course repo to the Integrated Machine Learning and AI organizational GitHub page. I'm working finally today on getting making sure that the files are caught up, because I did some unique new stuff that I haven't added. But now I'd like a Pareto for each feature. What are the number of NANDs and what percentage does that represent for all the records? So that's what this does. I calculate this just because I want to know it ahead of time. I can't remember if I even end up using it. But then the first thing I do is I just want to know the number of records. And that, of course, is the output right here. Then I'm creating a new series to just say, all right, is it a NAND? Sum it up, sort the values. So that is the first thing for the series. Then I say, I'm going to take that series that I've done the Paretos on, and I'm going to turn it into a data frame. So I'm taking by the way, a series is just a column, one of the columns in a data frame. In Pandas, several series make up a data frame, several columns make up a data frame. So I'm going to name that column that was a series, I'm going to take it to a frame and call it number of NANDs, which is right here. Then I've got this percent NAND Pareto series. So I take that original series and I divide it by the shape of the data frame, which is still just the number of, in this case, records, and I multiply it by 100. Excuse me, that's not the record, because let's see, hang on. Yes, the original DF coming in. So that's getting the number of records. So I can kind of normalize this to a percentage value. And then I add that as a new column to this new data frame that I created there. And basically, this is just a way to say, I don't want to deal, I'm not worried about the zeros. Zeros, don't treat them as NANDs. And then I return it. And so here I have this handy visualization. Let me try to get this just right. Of here are all my features that have NANDs. There's many more features than this, by the way. But the features that have NANDs, this obviously should be imputed. These that have very few missing values should be imputed. But now, when we get up into this range, this is where I'm likely going to just delete these features because there's just too many missing. And by the way, this is a housing data set. You can't really accurately impute whether there's a fence, an alley, miscellaneous feature. How is that helping me anyway? What value could I communicate back to anyone? Whether it had a pool, you really, okay, I've been a realtor. I am still a real estate investor. I'm telling you as a domain expert, I cannot impute these things, okay? So there's no way I'm gonna even try. Now, yeah, you might say, oh, Tom, based on the area and the number of pools in that area, yeah, I'm being too lazy. I'm just not going to do it. Okay. And, and as some of you know, sometimes having a pool actually takes away. But look at this. Only 7 realtors bothered to record whether it had a pool or not. Now, I could go in and look at those and say, well, for everyone that was reported, was it that there was a pool? And then I could possibly impute when there wasn't a pool, or there's a NaN for a pool, I can impute that that means there's no pool. The NaN means no pool. But I'd have to be very careful on these to impute. Above, from here and above, I would have to do it on a case-by-case basis. But I've just found this to be a handy visualization. Thought I would add it to Guy's already excellent lecture. And I'll stop sharing. I hope that was helpful. Guy, anything else?
Okay, from my side, nothing else. I'm just, if you have a question, I think if not, we can wrap up today.
Yeah. Are there any additional questions?
I have a question that might, it might actually be better suited, but one of the things that's occurring to me is in terms of data cleansing, you know, if there are specific types of classification errors that one should automatically be looking for, and which of these functions that you're describing. So for example, if you're looking for null values, you can try and figure out either through one-hot coding or through identifying which ones have, you know, less than one variable inside the column or the row. Is there a set of things that one should be looking for, and therefore, like within your toolkit, a number of types of procedures and functions that you could use that would apply to most cases, if that's
Kim,
possible to answer?
Yeah, no, Kim, let me see if I can rephrase it.
Okay.
And it's not because you didn't phrase it well. I want to make sure I understood it. As you encounter dirty data, you're going to come up with ways to deal with it. But is there some existing toolkit that deals with dirty data that you could use right away? Is that accurate?
Exactly.
Okay, that is a great question. I would say that's what Gaith and I are trying to do with our book, is to say there's no tool set, Kim, that we know of to deal with dirty data. It's more like if I don't know if you've had a friend that likes to build things and they go out there in their shop or their workspace, and sometimes they make a new tool or a jig or something like that. I would say Python itself, pandas, NumPy, even SQL, they have data cleansing they have pieces that you can use to build data cleansing tools. But what we're trying to do in our book is say, here's some starter tools, like that tool, the tools that Gaith just showed this morning, the tool that I just showed for getting the NaN density of a data set and the Pareto percentage-wise and number-wise. Those would be examples of tools, at least visualization for my part, but imputation on Gaith's part. The other tools that I have are ways based on, and Kim, it can change from data set to data set. So as you're looking at your specific data set, you have to decide while you're developing your machine learning pipeline, is this a feature that I'm going to impute, or is it one that I'm just going to fill with zeros or going to fill with the averages? And so if you're asking, is there a tool to automate that part? No. But once you know the kind of data that's flowing in to your pipeline and you're making predictions with it, or it may be a one-off too, Kim, like Kaggles are one-offs. That's the downside to Kaggle. You're not practicing with ongoing introduction of new data assets. That's the only downside to Kaggle. You're not forced to deal with that. But I think we can all imagine, okay, I've got new data assets coming in. Once you've developed the automation for that particular type of data, now you can automate the way you're dealing with the dirt that comes in for each feature. But it's kind of an acquired skill, just like a woodworker develops a skill for what jig to build to do a better job on their table saw for a particular project. A new part they have to make out of wood, that means they have to build a new jig, but a lot of the principles are still the same. So even though we're going to try to introduce some initial tools, Kim, it's really more about those being examples of how to build your own tools as needed, because dirty data it's often the same, but the way you automate dealing with missing values, for example, or dealing with a particular type of field that, oh, I saw all these cases and I developed a way to deal with each case, but I need some assertions in there that say, if you find a case other than the ones I'm doing, I want you to fail the code at this point and inform me of that so I can go build a new jig, a new data jig that deals with this new type of dirty data. Yeah, Guy.
I think your answer, Tom, is perfect. Now, I want to tell Kim something. For example, in our case, our main label, our main target is to find if this claim is approved or rejected, or this activity that we know, the activity-wise. If you check the dataset, I will also push it to the GitHub. You can find even this information, which is the label, the main label for us, is not fully available. Now, who will tell us how to fix this error is the domain expert, which is, I have clear information about how to do it. So for our case, we are going to see how to fix this error, how the labeling dirty appeared and how to fix it. In general, what we are trying to say that we are building a set of tools and functions, and then we are going to select from it what is suitable for our dataset. And this is happened a lot, we might find some datasets we need to build something new. So all of our tools for our experience, for whatever was, it's not enough. Now, especially when I think about something generic method of dealing with error. So that's why whatever we mentioned today, from my point of view, it's something normal. Let's say it's normal to think about this before start discussing the discussion about each and every column and value. This is something in general we have to think about it. We have to discard it. We have to finish it. So there is no, just like what Tom said, it's not something that we are one and forever. No, always we have to check and know exactly what we are going to do.
Okay, thank you. Yeah, it's interesting because it would be great if you could find ways to create identification loops and functions. So for example, if I'm looking at earnings and I know that the gross sales, for example, are certain figures and then there's sales tax that's associated with them, one way that I would look to see if there's any kind of discrepancy is if the sales tax doesn't match up with the total sales amount. So if I'm going through data like this, I'm trying to ascertain if these different functions can be used in multiple use cases. So I guess I'm going to look at what you post up and try and see, that way I can ask a better and more intelligent question.
No,
but I look through
actually, Kim, well-posed questions are an art and they're hard, but I think the way you've originally posed it here is extremely important. And let me point something out. What are we talking about here? Okay, it's kind of comical. Job security. AutoML cannot deal with this, by the way. This is the hard part of data science is for a specific flow of data assets that are growing over time, continually monitoring, oh, there's some new data dirt. I need to create a new filter and transformer for it. This is job security. Get really good at Python or R, get really good at data cleansing routines, the modules that you can use to do it. This is what makes data flow. It's just like, Like I said, I'm on city water. I'm sorry, I'm on well water. When I was on city water, I had this beautiful 21-year reverse osmosis water filter to give us the purest, healthiest water possible. And same thing with the data. I know we need to get off